question asks us to sketch the general form, so I'm just wanting the shape. Because you will be required to look at data and identify from its shape what the relationship is. So an inverse relationship starts high, curves down. Okay, so if that's your inverse relationship, ding, 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 well done. I'm going to leave that up for a second. I want you to go through and mark these. So you're giving yourself a tick or a cross, depending on obviously your performance. A positive linear, okay, that is any straight line with a positive gradient. So that could be this, that could be this, it could even be a negative C value. Anything with a straight line with a gradient that starts lower on the left and finishes higher on the right. Happy with that? That's a positive linear trend. That would be something like our Ohm's law sort of thing. Okay. A quadratic isn't a curved function. Now some people will have it like this. That's fine. I didn't specify whether it was a negative or a positive quadratic. Okay, and on the other side of the graph, it looks like that. Okay. Just to be clear, I cannot ask you, a lot of the time you won't get the back side of it, you just get one side of it, particularly in science, because where do we start most of our data in science? Zero, correct? We start at a 0 point. We don't often work with negatives in science. In maths, negatives are fair game. I can't ask you to do anything mathematically with that except for to identify the shape and interpret your data, identify, predict a point in the middle. Happy with that? I can't ask you what's happening up here or back here. I can't ask you to get me an equation for that line. I can't do any of that. Are we clear? Same as the inverse. Yep.
So you know how you've got like the other side where it goes like that? Can you have like that on that quarter of the graph? Like,
what do you mean? Yeah, so I can move across. Yep, you can. Not many relationships that you'll come across in high school physics follow that. You have come across one example. Does anyone know what that is? What happens to an object's displacement as it accelerates? So if you think about a falling object, so acceleration, if you've got an object that is accelerating, it will create a quadratic trend for a distance time graph. Or decelerating. Negative linear, again, anywhere like that, as long as it's got a negative, starts higher on the left than it finishes, then you've got a negative trend line. Clear with that? I can, with a linear, ask you to predict what's happening over here. I can ask you to develop an equation, that sort of thing. That is within fairness. A good test is if you've done it in general maths, I can ask you to do it. If you've done it in methods, I cannot ask you to do it. But your understanding of methods will probably help you identify certain trend lines a little bit more easily. Sweet? But there'll be no mathematical manipulation required. That is question 1 complete. Question 2. Determine the relationship between some weird set of data that I gave up. What's different about this data to the data I normally give you in this subject?
It's not perfect.
Most of the stuff I give you in this subject is not perfect. What else is different?
Tables is the wrong way.
Yeah, maybe. What have I given you?
X and Y.
What are they? More related to physics or maths? Maths, okay. So I've intentionally taken the context out because I want to focus on the data. In the data test, if I do this, you will not be given X and Y. What will we be given? 2 variables. One will be independent, one will be? Which one will be your independent variable? The X value, and your Y will be your? Dependent variable. I don't want you getting caught up in that, so I'm just giving you X and Y. Sweet? So we know that as X changes, what should Y do? Change with it. How it changes determines what type of relationship we have. Cool? What's the jump here? 6.2. What's the jump here? What's the jump here? What's the jump here?
4.2.
Okay, I should give you more data, but does that look like it's going up by about the same amount each time? What's this tell you? The fact that it changes a little bit?
Outlier?
Well, it could be outliers, could be a lack of precision, random uncertainty occurring. But looking at the fact that it goes up by a similar amount each time, what would I say? Positive, linear. Happy with that?
Yep.
Are we clear on how I knew that was a positive linear? If it was a quadratic, what would I expect to see? Would it be going up by an increasing amount?
Yeah, increasing amount.
Increasing or decreasing amount, okay? So if it went up by 10, then 7, then 5, then 3, clearly that's going to look like this, isn't it? Goes up by 10, 5, 10, 7, 5, 3.
Yeah.
Okay. If you're unsure, what could you do? Draw it. Very quickly draw it. Okay. Does it need to be perfect if it's not asking you to sketch it? It's just for your understanding. The second one, okay. I'm just going to go very roughly. 1, 2, 3, 4, 5, 5, 10, 15, 20, 25, 30. So the first one's 6.3, about there, just under 20, about there, 26, there, and the last one 30.6. Does that tell you that we've got a linear trend?
Yes.
Pretty clearly does. For our line of best fit, okay, it should have about as many points above as below. So I'm just going to draw approximately my line of best fit. That's not a great one, okay, but it'll do the job. I've got 1 point below, 2 or 3 above, 1 point above, 2 or 3 below, whatever. You shouldn't definitely have all your points above or below, and it does not need to intersect at 0, 0. Are we clear?
Yes.
Good. Sketch the above data, I've done that. Calculate the equation of the trend line. I can see that I've got a linear trend line, which means what? Y equals mx plus c. So let's come over here and start working this out. Y equals mx plus c. I don't know 4 things right now, but I can change that. Okay? Let's say I intersect this point and this point, for argument's sake. Maybe I'll go through whatever. Yeah, let's just go through 0.4. So I've got this point here and this point here that I'm happy with. That's the first point and the fourth point. Are we clear? I'm a bit loose because I've just said, look, pretty close, but you'd probably be a bit more accurate. You probably didn't do it by hand. So what can I calculate before I go any further? Gradient. M equals rise over run, or for those of us who have gone out of baby school, y2 minus y1 over x2 minus x1. Okay? Which point should be 2? Bigger one? Can be. The bigger one makes it a bit easy, but it doesn't really matter. Okay? I'm going to let it know. Let's just use 4 as my y2. So I've got 26.0 minus 6.3 divided by 4 minus 1, which is 19.7. 19.7? Yes, it is. 19.7 over 3, which is
4.925.
4.9. I'm pretty sure 3 times 18.
Oh, it's 3.
So 3 times 6 is 18, so it should be 6.57 works for me. So we've got now y equals 6.57 x plus c. Now we've got how many things we don't know?
2.
Y, x and c, but we can look at a point that intersects our line. I'm just going to say that point 4 intersects our line, correct? Happy with that? 4 looks pretty good. So when y equals 26, I don't need the point 0, I can put the point 0 in. When y equals 26, x equals 4. Cool. 26 equals 6.57 times 4 plus c. It's going to be what? 26 point something. 4 times 26.28 equals 26 plus c. C equals negative 0.28. My equation for that line is y equals 6.57x minus 0.28. There's my linear equation, done by hand. If I was doing this in a science report, would I do it by hand?
No.
I would use Excel or sheets. I would find my trend line. Okay, that will identify the best trend line using its computational mathematics. Sweet. Very good. Okay, some really good skills in that. If we can do that, we'll be very good in our math and our science, which is super important.